already graphed your two equations and found the area of the region that was bounded by the axes and the two inequalities. So now what I'd like to do is to recreate that scenario on our graphs page, and the first thing that we wanted to do was set the window to match the window that we were looking at before. So if you show a little bit of negative values, that allows you to better see your axis. So I recommend starting at -1 for x and let's go ahead and go to 12 for x, and then again -1 to 12 for y. And then we're ready to go ahead and input the values that we had. So the first equation was -x plus 8. Okay, and that line should look familiar now that you've already done this. And if you tab to get your function menu back, and we're going to do -2x plus 12. And that should give you your other line. By the way, if you would like to, you can make them inequalities so you can see where less than is. So I'm going to double click on this first one, and I'm going to backspace over the equals and put less than, and it will now shade the inequality. I'm going to do the same for F2. I'm going to make it less than. And now I can clearly see the region. That region is the region in purple, bounded by the axes and my two functions. Something else that you can do on your calculator is to add some points and lines. And if you just do a point on, you can find all those nice points using the point on function. So for example, if I then click on the graph here and slide my point, it should tell me when I've reached the intersection point and then display what that intersection point is. Likewise, I can find the boundary here of this function. So I clicked on the function once, and then it's showing the intersection point with the axis, which is also a useful thing. And I'm going to do the same down here with this graph and find the intersection point with the x-axis. And of course the point 0, 0 is the other boundary point. And I'm going to go ahead and add that point into the point 0, 0. So now I have marked the points that define my region whose area you just found. Okay? And likely you broke this region into a square and two triangles and use those to find your area. And I'll go through that at the very end. Alright, at this stage we're ready to go ahead and set up the Monte Carlo method. And to do that, the first thing I'm going to have you do is add a calculator page. And I just want to show you one of the things that your calculator can do. If you were to, on a calculator page, type F1 and open parentheses, and then type a number. So for example, F1 of 0, enter. This will find the value of the function when x is 0. Right? So if I go back here to my graphs page, F1 was the taller graph. Sorry, it must have been this graph right here was F1, and F1 of 0 is 8, and I can do that for any value. So I can do F1 or F2 of 4, all right, and I know that it goes through the point 44. If I check F2 of 4, likewise I get 4. And I bring this up just so you, so when I use this notation later, it's not unusual. Okay, so now we're going to add a lists and spreadsheet, and we're going to put our x values, so x underscore value, and our y values into lists. Now, these instructions are on your sheet, so please follow along with those as we do this, and we'll go from there. So if I'm going to go back to our calculator page really quickly and say rand, open parentheses and close parentheses, enter. Rand gives me a random number that's between 0 and 1. Okay, that's what it returns. And if I did it again, so I can just go up and grab it and do it again, it gives me another one. And if I hit again and again and again, it just gives me random numbers somewhere between 0 and 1. Okay? And what I would like to do then is create random digits, but I need to plot points randomly within a region on my graph. So I think the best region is one. I'm going to go to geometry and add a shape, and I'm going to add a rectangle, and I basically need to get my entire region within it. So the smallest rectangle I can make is one that goes 8 units high, and I can't see where I am. Let's see, I'm going to escape. We're going to try this again. We're going to start down here where I can see how wide I need to go. Okay, we're going to go from that point to that point, and then we're going to go up until we hit that top point up here. Now if I define my rectangle like in our original setup, we had a rectangle that was enclosing a circle. Now my region, that purple region, is completely enclosed by this rectangle. And this rectangle is 6 units wide by 8 units high. Right? And so what I would like to do then is to plot points that are between 0 and 6 and between 0 and 8. If I use random integer, I'm missing out on all of the fractional values between the whole integers in terms of plotting points. So I don't want to do that. And if I do just the rand, I only get numbers between 0 and 1. So what I'm going to do is multiply my rand by how wide I want it to be. So for example, in the x direction, my rectangle was 6 units long. So 6 times rand, open and close parentheses, enter. This number now is somewhere between 0 and 6, because 0 times a random number would be 0, and 6 times a random number would be, if that random number is 0, which is the smallest it would be, it'd be 0. If that random number is 1, the largest it could be, then 6 times 1 would be 6. So by multiplying by my width, I'm getting numbers now that will always be between 0 and 6. For y values, you want them to be between 0 and 8. So I'm going to multiply this by 8 times rand. And the last thing that I would like to do then, before I start to fill this down and plot thousands of them, is I would like to test whether or not this coordinate 2.7, 2.6 is in my region. Now if I just visually go back here, this is 1, this is 2, 2.6, what is it? And then 2.7, I should be landing within my region. So this should come out to be a true when I do my statement. Here you're going to do an AND statement. And the way an AND statement works is if the AND statement is true, then it returns true. And if it's false, it returns false. So what I'd like to know is this coordinate meeting both of my inequalities that I have graphed? Okay, so to do that, we're going to do B1, which is the y value, which is 2.61. is B1 less than F1 of A1. What that is testing is the y value that's in this cell less than the y value that's returned by negative x plus 8, okay, when I plug this x value into that function. That's basically what it's telling me. All right, and then I'm going to type the word and. B1 is less than, and now I want the other function, F2 of A1. So I'm testing, is it meeting inequality number 1 and inequality number 2? Oh, did I not put an equals sign in front? Don't forget the equals. Okay, and it is saying true, which is good, because I already tested that that point should be in the region. Now if I highlight all 3 of these cells and drag down, I'm going to do it just for a few, and all of these look like they are possibly within my region. Let me see if I can get a false. There we go. So I just want to test this 4.7, 6.7. So 4.7, 6.7. is outside, okay, outside my region, and so I know that my function is working. Once you know that your function is working, then you want to just drag this down for a very, very, very long way. Keep track of where you let go so that you know how many cells you've plotted, and I'll just help you with what you're going to do from that point on. I'm going to just say points plotted. I put the quotation marks in because it allows me then to write words and put spaces between those words. You don't have to. Right now I know that I stopped in cell 8 or in row 8, so I know that there were 8 points that were plotted in my box. Okay, and the next thing I'm going to count is number in region. And to count that, I'm going to do equals count if, open parentheses, and you need to tell it the range of values. So I can highlight this, or I could just type in C1 colon C8, comma. So you're saying count if in this region, comma, it says true. So I'm going to type the word true and then enter. And you can just verify that this is counting correctly. 6 of them were true. Then I would calculate a proportion. So I would do equals the number that are in the region divided by the total points plotted, and that's the proportion that landed in the region. Okay. And I would do then, that's the proportion of values that are in the region. Now I want to convert that to an area. Alright, so the area of my total box, the rectangle, is equal to the width of my box, which was 6 units wide, times my height, which was 8 units high. And then the area of my region is last. And the area of my region would be this proportion that I got of points that are in the region multiplied by the area of that overall shape, the overall rectangle. Now obviously this is not close to the actual area, and the reason is it's based on only 8 points. So what you want